So when you talk about LLM or large language model, the first thing that comes to our mind is ChatGPT, right? So we can ask any question and it can answer almost everything, right? So also if we have explored a little bit more, so you would know about Olama, Anthropic, or Gemini, or the recent buzz, the DeepSeek. So this all these LLMs you will know about, right? But how these LLMs work? So hi, this is Devstuti. I would like to discuss a little bit about LLM in this video. So first think about language model. What is a language model? So when we ask something in ChatGPT, so it generates some sentences or paragraphs, right? One word at a time, literally. So how does it do that? So like if it has generated few words, how does it understand? Like how does it decide like which word should come next, right? So that's the basically the idea of language model. So here we have one example. The brown fox jumped over the. Then we have three options. It can be either road, fence, puddle. Like how do we decide? So I'm just showing a simple example here. It can be, we can have multiple options, right? But how does a model and know, right, which one should come first? So if we think about a traditional probabilistic model, right? So in that case, we'll choose the word with most probability, right? So the next question comes is how do we actually calculate the probability? But that's a different question. We can see that. But basically, our main goal here. So suppose if we have generated few words, right? We want to know which one word should come next. Like here, if we have generated W1 to WT, right? So then we want to know the probability of WT plus 1. So that's what pretty much what language model is about. Now, how do we calculate the probability? I'm just giving a basic intuition here. So this is not how the way language model work, but let's say we have generated the quick brown, right? Then what's the probability of the next word to be fox, right? So P of fox, given that we have already generated the quick brown. How do we calculate that? So initially we are having a training data set, right? So in the training data set, if we just check the occurrences of the quick brown together and also the occurrences of the quick brown fox, right? So if we check this frequency or count of this four words coming together or three words coming together, and if we use that to calculate the probability, so that is one way, right? So we can use that to decide the probability of fox coming after the quick brown. So this is just to give the idea. This is not how the way we create language models, but this is just a basic idea. So how the language model we actually create? We use neural network models where there is a popular framework, a popular architecture called transformer architecture. So this is an encoder decoder based architecture that's basically we use for for generating language models or the large language models. Now, one of the basic core building block of transformer architecture is attention mechanism. So I'll just give two example here, two sentence basically. One is the animal didn't cross the road because it was too tired. And the second one is the animal didn't cross the road because it was too wide. So if you see in the first sentence, it was too tired. Here it means the animal, right? Because the animal can be tired, the road cannot be tired, right? And in the next one, the it was too wide. Here it means the road, the animal cannot be that much wide, right? So when we are generating a next word, whether here if you see the word tired or white, right? When we are generating a new word, we are not only seeing what all words we already have, we are just seeing how much attention should I give to each of the already generated words, right? So that's a better way to create a language model. If you see in the first sentence, the word it, in this it was too tired, the word it has uh, very high attention with the word animal, because it was tired, right? The animal was tired. And also the animal word animal has a high attention with the word tired, but it has a low attention with road, it has a low attention with tired. But in the next one, here it was too wide, here it has a high attention with road, also it has a high attention with wide. But it has a low attention with animal, and animal has a low attention with wide, right? So here basically for each word we just calculate the attention score, and we use that to create the next word, right? So that's a little bit complex, not I'm not showing it in depth here. I'll be discussing transformer architecture in depth in one of my upcoming playlists. So there I will be discussing these things in detail, but here I'm just giving the idea, the basic building blocks of large language model. So now we have seen what is a language model. Now we have seen the building architecture, that the transformer architecture, that is the building main architecture we use in most of the like most of the large language models like ChatGPT, Olama, Anthropic, or any recent ones coming up. And next, we will be seeing large language model. So, large language model is built using the transformer architecture. It is trained on, these are trained on vast amount of text data. So that's the difference. That's why it is called large language model. That's because it is trained on how like huge amount of data, right? It acquires broad understanding of the language, the context, the complex patterns, and general knowledge. So it understands the language and the nuances and all. So when we ask questions, it can answer things that from the knowledge it gathered from the training data set. So this is the basic of large language model. Now, if we have a specific task, we can fine tune the large language model as well, like for sentiment analysis, for a special kind of question answering. We can train with a smaller task specific data sets, and it will work for our own data sets. So suppose there are other ways to do that. So RAG is one of the way that works. Suppose if you're working in a company and you have some company specific data, let's say sales reports or revenues or some other thing, some thing that only makes sense to your organization and all, right? So we can feed those data. We don't need large amount of data, and we can and if we can either fine tune, and there are other ways like RAG. So we can use our small data sets, small space task specific data sets, and then we can work with that as well. So next we'll be discussing RAG. So there will be saying we'll be using large language model, LLM, and vector database, and we'll see how we can work with how we can use this tool like LLM and vector database to work with our own type of data.